Okay, so we're moving on to Chapter 17, which is sampling distribution models. Today we're going to focus just on proportions. And so when you have a proportion, remember proportions are when you have things for categorical data. So they have to fit in the categories. And so proportions is a nice way to start because it's very similar to Bernoulli's trials. You can only have a P, which is a success, and Q, which is failure. The other thing that I'll always list is N, and N is the number of trials, or not number of trials, but sample size. Okay. When we find the mean and the standard deviation, the mean is just P. Whatever you think P is, or whatever it says P is, that is the mean. The standard deviation is this formula: the square root of PQ divided by N. So you have to make sure all of that is underneath the square root. Now, we're getting to the point that you have to check conditions, and it's much more important than all the other stuff we've done this year. So with conditions are the assumptions to check. Those are the two ways you're going to hear about it. The first thing you have to do is you have to say that they are independent from each other. And you can't just do check marks. You have to actually write a statement about why it's independent from each other, or use context to say that it's independent from each other. The next rule is that it has to be less than 10% of population. And this kind of solidifies independence. It also ensures independence. But you have to say it. The third thing is, it has to be that it's random. If something doesn't say that it's random, you can assume random. Let's write that in a different color. You could say assume random, and you're going to proceed with caution. But a lot of times it's going to say it's random. But if it doesn't say random, you could say we're going to assume that it's random and we're going to proceed with caution. The last thing that you have to have is you have to have enough success and failures. And remember, this is where you have to have at least 10 successes, which is, you find that by NP has to be greater than 10. And you also have to show that you have at least 10 failures. So NQ is greater than 10. So these are our conditions we have. Okay, so let's look at some problems. So of all the cars on the interstate, 80% exceed the speed limit. What proportion of speeders might we see if we look at the next 50 cars? So whenever I see a percent, I'm going to go ahead and list all my parameters. My P is 0.80. My Q is 0.20, because remember, the P and Q have to add up to 100%. And my N is the 50 cars. Okay, so what it's asking us to do is to draw the normal model, and then we're going to answer this where it says what proportions might we see. We're going to answer that by finding the middle 68%. So I do need to figure out my standard deviation, which is the square root of PQ over N. So that's going to be the square root of 0.80 times 0.20 divided by 50. So that is 0.057. Now, I would not round this to 0.06. Stop it, dog. Sorry, guys. I would not round it to 0.06. I would keep always two numbers. And I don't really always consider 0 a number. Okay, so what we're going to do now is we're going to draw a normal model with using 0.8 and 0.057. Okay, so let's draw the normal model. Our mean goes on the right, 0.80, 0.857. Oops, I don't have to write it sideways. So it's 0.857 and then I add 0.057 again, and I get 0.914, and then I do it again, and I get 0.984. And remember, I always like to make the mean a little thicker so that I know that's the middle. And then I have to do 3 standard deviations on the left. So 0.8 minus 0.057, which is 0.743. So I don't have my graphing calculator, so I'm not super fast at this today. But you're okay. Gives you time to write it down too. Okay, so remember the middle 68% is right here. And so our middle 68% is from that number to that number. Okay? And so how we're going to interpret this is we're going to say, and here's one thing that's important is, you guys remember each sample is always going to be different. And because you're always going to be dividing by a different n for a different sample size, the spread of it's going to change. And so when we describe the sample, it is important to say with a sample size of however big it is. So let me change the thickness because that's pretty small. Okay, with a sample size of 50, we will see between 74.3% and 85.7% of drivers speeding 68% of the time. That's where the bulk is. The majority of it is in between one tick mark to the left and the right. And so we talk about those 2 tick marks and then we say within 68% of the time. But you notice I said with a sample size of 50. So that's what you're going to see the most. You're going to see between 74% and 85% speeding. Okay, so for this next one, what we're going to do is we're going to use the same information because we have the same 50. And so we know our standard deviation is the same. And so now we're going to try and figure out if 50 is rare. And remember, what you have to do is you have to start off by drawing a normal model, and you always put your mean in the center. Okay. Now the question is 32 out of 50 rare? So we have to figure out what 32 out of 50 is. And 32 out of 50 is 64%. So 64% would go over here. Okay. Now, if we were really accurate, we would look up here and we would see it would be right up here, closer to 3 standard deviations away. But that doesn't really matter. Our picture is just a reference so that we understand what we're doing and how we use our calculator. Now, whenever you're on the left side, you're going to shade to the left. And so I'm going to use my normal CDF, shading to the left at 64. Okay? Now, I do not want you to write calculator talk. I want you to write what the model is you're using and a picture. That's all you need. And then you know how to use the calculator. And that's especially important for AP stats. And calculator talk is not really accepted. Doesn't really give you points. Okay? All right, so now let's pull up the calculator. So to do this, I'm going to do second distribution, normal CDF. Lower is a really small number. This is as small as it gets because it's a huge negative number. And then for upper, my upper is 0.64. Now, if you didn't want to type in 0.64, you could have done 32 divided by 50. But then you wouldn't know if it's on the left or right. So I always find the decimal. But this is what happens when you do that. See, sometimes it'll put in the decimal, and that's okay. And then my mean is 0.80. I'm going to put this back up here so people know. And then my standard deviation is 0.057. This is where if you use 0.06 versus 0.057, it could make a difference sometimes. Okay. And so what we get is we get 0.00, what was it? 25. So that's 0.25% of the time. Yes, that is strange. That is a super small number. Yes. That happens only 0.0025 of the time. So that is definitely rare. Okay. Usually our cutoff, remember our magic cutoff is 5%. We are going to get into more of that why it's 5% later, but right now that's what we have. Okay, so now it's asking what percent would be abnormally high. Well, we're still using the sample size, so our standard deviation is the same. And so usually anything abnormally high is 2 standard deviations away. So this would be 2 SDs above. And if you look up here, that's right here, 0.914. So if we see 91.4% of drivers speeding, that would be abnormally high. Now, if they asked you how many drivers, what we would do is we know that it's a sample size of 50 for this, so we would do 0.914 times 50. Let's see. So anything over 45.7 would be abnormally high. And it's okay to keep the decimal. Like it doesn't seem like it makes sense because you can't have a decimal of a car, but it works. Okay, so same idea for abnormally low. Abnormally low would be 2 standard deviations below. I'm drawing through it, not highlighting it. So that would be 2 SDs below. Which would be 0.686. Okay? And I'm not going to explain it like I did here, but you would explain it the same way. All right, let's go over the next problem. Groovy M&Ms are supposed to be made up of 30% of the candy sold. So in a large bag of 250 M&Ms, what is the problem? We get at least 25 groovy candies. I think we did a problem earlier this chapter where groovy is the speckled, right? The polka dots. Okay, so we're going to check the conditions. So let's look up at our conditions. Independent, less than 10%, random, success, failure. Okay, so let's see. Oops. Make sure. Okay, so candy type is independent of each other. Uh, 250 M&Ms is less than 10% of all M&Ms. It doesn't say random. We're going to assume 250 random candies. And then now we need to do our success failure. So we're going to do... now here's the thing. There's 2%. So what percent are we looking at? If we look here, it says 30% of the candies, they make up 30% of the candies. That's the one we're looking. This second number is we're trying to see if that's a strange number, if that's really small compared to 30. So we have to do our NP. So 250, oops, got my 0. 250 times 0.30. Let's see what that is. I think that's like 75. Yep, 75. That's greater than 10, so that shows that that's okay. And you could do a check mark for this. And then for this other one, you could either do 250 minus 75, or you could show 250 times 0.70, which is 150. That's also greater than 10. So that's how you check your conditions. I don't really have a lot of space. I don't know what I was thinking here, so let's squeeze it up here. Normal model. Middle is 30%. So now we need to do our square root. So the square root of 0.30, 0.70, and 250. I also should have listed my P. I did not do that like I said we should every time. So you got to list those parameters. Parameters are things that you use. Okay, so let's open up our calculator. So second square root, 0.3 times 0.7 divided by 250. And so I get 0.029. So now I'm going to use the normal model with 0.30 and 0.029. And you notice it does say clearly label. Remember we did this before. Clearly label is adding those 3 tick marks to the left and right. So I'm going to need probably thinner. So, whoa, that's really thick. I wanted thinner, and that was not the deal. Let's go thinner lead. So we're going to do 0.3 plus 0.029, which is 0.329, plus 0.029, 0.358. Plus 0.029, 0.387. Then we have to do the same thing on the left. So 0.3 minus 0.029, 0.271. And I'm not double checking my calculator, so hopefully I'm not making mistakes, but it definitely could happen. Okay. And then the last thing we have to do for clearly label, remember you make the lines. 1 tick mark is 68%. From 2 to 2 tick marks is 95%. And then from 3 tick marks is 99.7%. Okay. Questions so far? Hopefully you're doing okay. You rewound it. Okay. And then we still, gosh, I did not give you guys enough space for this, and I apologize. I'll probably change my notes so that you have space. So we still have not answered this problem. What is the probability that you get 25%? And so let's just change part B to that. My note says something different than yours, but that's okay. So we're going to do this right there. Okay, so 30%, 25%. Now, the rule I usually say is if it's on the left, you shade to the left. If it's on the left of the mean, you shade to the left. If it's on the right, you shade to the right. But look at what this says. Let's do purple. This says at least 25%. It's specific there. A lot of times they're not as specific. Since it says at least, that means on the right. So I'm going to shade this right side. Okay, so now I'm going to use my calculator. Let's see if we can open it up. Let's move that over. I'm still going to use this mean in standard deviation. So second distribution, normal CDF. This time the left is this line right there, 0.25. And now I pick a really big number. This time our mean is 0.3 and our standard deviation 0.029. And so 95.7 or 95.8% of the time, you're going to have 25% or more. So that would be the answer, 0.95. Was it a 7 or 8? 958. And that's the answer. Okay. So you've done a lot of these different parts before separately in different chapters. Now we're kind of putting them together. Remember, it's important to check conditions using sentences or using bullets like this and use context. You do have to be able to calculate the standard deviation on your own, and you do have to memorize that formula. I do not think that's one that's given to you. I'd have to look, AP kids. And then you draw the normal model and you shade.